Imagine asking your factory machines a question in plain English and getting an instant answer. With AI, you can now talk to your industrial IoT system like you would talk to a colleague. Ask for live pressure readings, check vibration levels, or change pump settings. No need of any dashboard or technical menus. Just type what you need and you'll get a response. Hi everyone, I'm Hariharnath and welcome to IoT Frontier. Today we are taking our Model Context Protocol MCP integration to the next level. We'll configure realistic industrial sensors in the process OPC UA simulator and read multiple data points like vibration, pressure and flow rate, and also demonstrate how to write data back to the server to control a simulated pump. So let's get started. On the right hand side you can see a pump. So there are so many properties it would be having. Some are readable and some are writable. And here in this project, we are going to use 3 readable properties and 1 writable property, and then try to show you both ways of doing with the MCP protocol. And here you can see we are using Python MCP server, which will be acting as a OPC UA client. So it will connect to your OPC UA server using OPC UA protocol, and then it will be using Claude Desktop as an MCP client, and then query this MCP server so that we in turn query this IoT system so that we get a values of whatever we want to read, also write to them back. So to do this, we are going to use process OPC UA system. So for that you need to get into process OPC UA simulation server, and in that website you need to fill some form so that you will be able to get this URL to download the exe file if you are using Windows, and for other OS we can see the links. So then you need to install it. So you can see from the start menu process, and for the first time you might see a basic menu. You can also switch back to the basic menu, and if you want to get into expert mode you can do, but there is no need of that. So first thing you need to notice is this connection address. So you need to copy this, and also you need to open something called UA expert. So this is the OPC UA client, so that we'll test whether our server is properly working or not. So from Google you can find out the link of this download, and here you can see you need to log in to download. So once you log in you can download it and install it. So I have installed the UA expert. I'll just open it, and this would be the OPC UA expert. So from the server you need to click on add server, and here you need to go to custom discovery and click on the add server. So here you can paste whatever you have copied from the process. So click on OK, and now double click on this. You can see simulation server, again double click so that you can see different methods to connect. So I'll use none as a security method and click on OK, and here also anonymous for the testing purpose, and OK. Now you can see all its different objects that are available. I can see the simulation values. So I can go back to the process, and under the objects you can see simulation. So you can click on this simulation and you can see different already defined variables such as random values, and you can see the random values keep generating, and here in the value you can see from where the max and min value is set. So like this we are going to create 4 values for us so that we can use those for our project. So first I'll just select random and click on duplicate. So I'll select as 4 so that I'll create 4 nodes separately, and we can see the naming 2, 3, 4, 5. Okay, so first random 2 we can just go here and edit. So first one we are going to create a vibration. So just click on OK, and inside this value you can see you need to make sure this value is random, and also disable this. So from the minimum and maximum value we can keep vibration to be like 0 to 10 values, and it will change here immediately. And same way we'll do for the rest of the things. And only for the pump speed I'll try to keep it constant, and remaining all has been defined and created, and initial value I can keep it as 0. Now we can see this is completely running, and we can go to UA expert and we can click on rebrowse from simulation. So click on this, I'll expand here. So here you can see the simulation server and click on rebrowse. So you can immediately see the values: flow rate, pump speed, pressure, and vibration. So you can see the vibration values is matching with this. So this is how you can verify with UA expert. So now I can simply minimize this UA expert. So next thing is we'll try to create a MCP server with Python. So first make sure your system has a Python. So first open command prompt and check whether you have Python or not. So you can see if you type Python, you can see that Python 3.12.4 is the version that I have installed. Using exit, I'll exit this. Now that we have Python already there, we'll first create a folder called MCP server OPC UA inside documents. So I'll go to documents first. Next, I'll try to create a virtual environment inside this using this command. And after that, I'll simply activate the virtual environment. So once this is activated, you can see as a prefix virtual environment would be there. So next you need to install MCP and asyncua, which we are going to use in Python code. So enter the pip install so that it will install all the necessary packages. So once that is done, you can simply create a Python code. So I use VS Code, that's why I wrote code OPC UA MCP server.py. So it will open VS Code, and here you need to paste the code. So this code I will be providing in the description. The only things that you need to change is the OPC UA URL as well as the nodes. So here you can see the vibration and everything is matching from the process. So I'll show you. So you can see this is vibration, and in the attribute you can see 1008. That is what written here. And for pressure, and what this is 1009, flow rate 1010, pump speed 1011. So you need to match this namespace and identifier exactly, then it will properly work. And in the code I'll simply give you a glimpse of it. So first we are enabling the fast MCP, and we are giving different functions like reading the OPC value and writing an OPC value, which is generic values. And then you can see MCP tool is created, which means these tools are available for us from the MCP client such as Claude Desktop to get the values. So now we also provided what it does. This tool does is it provides the telemetry from the industrial station that we have. So it provides vibration in this format. So what are its units, everything is mentioned, and also how to read them, that is also mentioned here. So we're going to use the function that is mentioned above. And another tool is to write or set the pump speed. So here also there is an error called, if the value is given more than 0 to 100, or if it is not the value, then we'll get an error here that it should be between 0 to 100. That kind of error handling is mentioned. Otherwise it will write the values into that pump speed and gives us the success message. So this is how simple the code is. You just need to save it and simply minimize. So next thing that we need to do is we need to modify the JSON file of Claude Desktop, which is the configuration for it. So you need to mention this command. So it would be there in app data claude desktop.config JSON. So I'm using Notepad for this. So you can simply enter this value. So Notepad will be open. So in the Notepad, I'll be having these values to be entered. So I just replace this with an updated ones, and the remaining values are same for me. So because I have already tested this, so you can see the correct path has to be provided, that is documents MCP server OPC UA, and here also documents MCP server OPC UA and the Python file. And the remaining below ones is the default one provided by Claude. So even if you remove it, it doesn't matter. So you can just save this. Now because Claude might be already running, we need to quit this first and then again restart the Claude. And here in the Claude you can see under files, settings, go to the developer, and you can see whether industrial station is running or not. So there is a typo here. I'll just update that. So now we can see industrial station is running, and these are the commands and arguments. We can also see the view logs, so that if there is any kind of error that you are facing, you can use this log file to find out where the issue is. So now go back to the chat, and here you need to select connectors, and you can see this should be enabled. Now we can ask what is the current status of our IIoT station. I'll use a different wording, but Claude would be able to identify it properly, which tool to use. So the first time it will say it wants to use the get station telemetry tool from the industrial station MCP server. So it has already found out that from here it can find this value. So I need to click on always allow, or you can use allow once. So I'll use always allow. So now you can see it has given me a table where the vibration value at that second is provided, and pressure value and the flow rate. You can also see the units are automatically taken from the tool description. In the code we have given this as a description for the tool, and it has taken from here, and it is saying that these are typical operational ranges. There is no issue for that. Now I can say the flow rate is below my threshold, so increase the motor speed to 95. So let's see what it happens. So with this command, it is not just reading, it is going to set the value of motor speed also. So let's see if it is using a different tool. So now you can see it is using a different tool called set pump speed in the code. So we need to allow it also for once. Now we can see the value has been set. So we can cross verify that from the UA expert. So you can see in the UA expert, the pump speed is 95. So I'll run them side by side and make sure we can see them properly. Update the pump speed to 35 now, as the values are good. So immediately within seconds it got updated here. Even before we got a response here, it is updated here. Now we can also use something like beautification with the LLM. So you can use the full power of LLM here, so that whatever the values that are coming, we can simply show them as a dashboard values. So I simply wrote that show it in different tiles with the different colors as if we see in a dashboard. So now let's see how it shows. It will take at this second what are the values, because every second these are getting changed, but in reality these might be, some might be changing, some might not be changing. So now you can see the values are getting updated as a tiles as if we see in a dashboard. And this is the true power of bridging large language models with industrial projects. We have moved beyond just monitoring the data. We can now dynamically orchestrate and control our machinery using natural language. If you found this video informative, please type helpful and smash that like button. If you wanted to learn IoT from scratch, then you can check out my course on Udemy from a link in the end screen and description. Your support means a lot to us and helps us keep creating more content like this. So please subscribe to the channel and hit the bell icon. Thank you for watching, and I'll see you in another interesting video.